So, good afternoon, students. Today we are going to solve some of the numerical problems on operational amplifier. Okay. So, in university examination, in RQ type pattern, more weightage is given on the numerical problems. So it is very much important how you attempt this numerical problems. So, in case of inverting amplifier, so what is inverting amplifier? When you have supply input to this inverting terminal and output is obtained, this output is equals to R2 divided by R1 into the input voltage. This output will be the ratio of resistance in the feedback divided by input resistance. So here R2 is in feedback, R1 is in input into the input voltage, and output is a negative because we have supplied this input to this inverting terminal. That's why output is a negative. So this is the output for the inverting amplifier. Now what is the problem? Problem is find the output voltage if the input voltage is 0.6 volt and the resistance R1 is equals to 10 kilo ohm. Okay, that is your input resistance, and R2 is equals to 5 kilo ohm. So then here we'll go for now solution of this equation. So what is output here? The output equation is output is equals to minus Rf. What the resistance in feedback is R2 and input resistance is your R1 into the input voltage. So here what are the given quantities are there? So here R2 is equals to the resistance R2 is equals to 5 kilo ohm. Okay, and what is the value of R1? R1 is the input resistance. Input resistance is equals to 10 kilo ohm. Okay, and what is the value of the input voltage? The value of input voltage is 0.6 volt. Okay, so if you substitute all these quantities, we will get output is equals to minus. What is the value of R2? R2 is equals to 5 kilo ohm. R1 is equals to 10 kilo ohm, and what is the value of input resistance? It is 0.6 volt. Okay, so this will be equals to 1 by 2, and this will be equals to your 0.6 divided by 0.6 divided by 2. So this is equals to your, this is 0.6, so this is equals to your 0.3 volt. Okay, so what is the output voltage? So here output voltage is equals to your 0.3 volt in case of this inverting amplifier. Okay, so in this way there are problems will be given to you, and you have to solve these problems. So if you take the second problem, here in the second problem, what is given is the, what is the problem? The problem is find the input voltage if the output is 6 volt. Here what is given is, in previous problem we have to find out the output voltage. In this problem we have to find out the input voltage. If the output voltage is 6 volt, input resistance is 500 ohm and feedback resistance is 5 kilo ohm. Same problem it is. Okay, so first upon write down the equation. So what is the equation for the output voltage? The V output is equals to the minus, here we have to take Rf divided by R input into the input voltage, right? So first, what are the given quantities are here? What is the feedback resistance? Feedback resistance is equals to your 5 kilo ohm. Okay, so what is 5 kilo ohm? 5 kilo means it is a 5000 ohm, right? And what is the input resistance? Here input resistance is equals to your 500 ohm, right? And what is the output voltage? So output voltage is equals to your 6 volt. So what you have to find out? You have to find out the input voltage. So what is the equation for the input voltage from this equation? Equation number 1. So input voltage is equals to minus input resistance divided by feedback resistance into the output voltage. Okay, so substitute the value. What is the input resistance here? Here input resistance is 500. And what is the feedback resistance? Feedback resistance is 5000. And what is the input voltage? Input voltage is your 6 volt. Okay, so this will be equals to 1 by 10. So this is the 6 divided by 10 means this is equals to your, this is equals to your minus minus 0.6 volt. Okay, so this input resistance will be minus 0.6 volt. So here observe that here this input resistance is minus 0.6 volt, this input resistance is minus, and you will get output plus. So there is a change in the phase by 180 degree, hence it is a, this terminal is the inverting terminal. Okay, so you can try this problem is also, this is somewhat not so much but somewhat tricky, that you have to find out the feedback resistance here. So in an inverting amplifier, the closed loop gain is given, gain is equals to minus 50, and we have to find out the feedback resistance, and input resistance is given, R1 is equals to your 50 kilo ohm. Okay, so simple here, gain is actually, what is the gain in the closed loop? The gain is equals to minus RF divided by R input. Okay, so here input resistance is equals to your R1 resistance. Okay, it is 20 kilo ohm. And what is gain? Gain is given, that gain is equals to minus 50. Okay, so simply you have to substitute the value of RF and RI. Here gain is given in terms of negative, so don't take negative sign. So you are in this way, here A is equals to minus 50, here is equals to your RF divided by R1 is there. So substitute the value of that input resistance and multiply it with the gain, and you will get the feedback resistance. So this is about your inverting amplifier. Now we are going to learn about the problems on non-inverting amplifier. So what is non-inverting amplifier? If you supply the input voltage to this non-inverting terminal, and this inverting terminal is made ground with resistance R1, and this output is feedback to the inverting terminal through resistance R2. So here feedback there is a resistance R2, and input resistance will act as a R1, and we have to supply input voltage to this non-inverting terminal. And what is the output? Output is equals to input into, in bracket, okay, it is in bracket, 1 plus R2 divided by R1, or you can take this RF divided by R1, because this R2 is nothing but the feedback resistance. So what is the problem? In an inverting amplifier, so here there should be a non-inverting, we are going to take non-invert, that non-inverting amplifier, so this is not right, here should be a non. In a non-inverting amplifier which has the input resistance, what is the input resistance? In a non-inverting amplifier has input resistance 4.7 kilo ohm, and what is the feedback resistance? 47 kilo ohm. You have to calculate the output voltage if the input voltage is 0.7 ohm. So how will you going to solve this problem? So first upon, write down the equation. So what is the equation for the output voltage? So 1 minute. Okay, the output voltage is equals to the, here there is a no negative sign, input voltage into 1 plus the resistance in feedback, or R2. Here it is R2 divided by R1, feedback resistance divided by input resistance. So what are the given quantities are here? Here What is the input voltage? The input voltage is equals to your 0.7 volt. Okay, and what is the value of feedback resistance R2? The R2 is equals to your 47 kilo ohm. Okay, and what is the value of your input resistance R1? R1 is equals to your 4.7 kilo ohm. So substitute this value in the equation. Output voltage is equals to the, what is input voltage? 0.7 into, what is this? 1 plus, what is the R2 value? 47, it is kilo ohm. And what is the value of R1? 4.7 kilo. So this kilo will get cancelled. 4.7, this 47 means this will be equals to 10. So this is equals to your 0.7. This will be 1 plus, this is the 10. 1 plus 10 means this is 11. So this is equals to the 7.7, 7.7. Okay, and what is the unit of voltage? The voltage will be volt, so this will be equals to 7.7 volt. Okay, so this is the your output. Okay, so what is the result? The output voltage, the output, 1 minute, we will take the point. So this output voltage is equals to 7.7 volt. Okay, so you have to write here the output voltage is found to be 7.7 volt. Okay, so in this way, this is the problem on your non-inverting amplifier. This is also one of the problem. So if what you have in non-inverting amplifier, the as shown in the figure, there we have to calculate the output voltage. If the input voltage is 0.5 volt and 2 volt, means we have to find out two output voltage. For first we have to find out the output voltage for 0.5 volt, then we have to find out the output voltage for 2 volt. Okay, so what is the formula for the output voltage? The output voltage is equals to input voltage into 1 plus Rf divided by R1. So if you consider this first condition, 0.5 volt input volt, so substitute this value. Input voltage is equals to 0.51 plus, what is the feedback resistance? It is given in your diagram here. So feedback resistance is 20 kilo ohm. Here this R1 and this R1 both are same, 10 kilo ohm. So you can substitute any one. So 20 kilo ohm divided by 10 kilo ohm. So this will be equals to 2. 2 plus 1, that is equals to 3. 3 into 5, that is equals to 1.5. 0.5 into 3 means 1.5. So that is output voltage is equals to your 1.5. Then apply the same condition for taking 2 volt. You will get the output is equal to 6 volt. So in this way, we have to solve the problems for inverting and non-inverting amplifier. Next, we are going to learn how to solve the problem on adder. So if you supply the three voltages V1, V2, V3 through resistance R1, R2 and R3 to this terminal, which terminal? Inverting terminal, and we will get output. So here we have supplied these voltages to the inverting terminal, so we'll get output also negative. Okay, so this is the equation for your output, and this will act as a adder. Okay, so when this will equation act as a adder, if your uh, all values Rf is equals to R1 is equals to R2 is equals to R3. If all these four resistance are same, then what is your output? This output will be is equals to minus. Why there is a minus? Because it is input is given to the inverting terminal. So output is equals to minus V1 plus V2 plus V3. So here it is act as adder. But what happens? Sometimes it is act as a adder, but if these resistance are different, it will perform the addition, or it will perform the addition with respect to the input voltage and R1 resistance. Okay, so that is the problem here. Find out the output voltage of operational amplifier which is working as the inverting adder and having resistance R1 is equals to 1 kilo ohm, R2 is equals to 10 kilo ohm, R3 is equals to 100 kilo ohm. Here the resistance are not same. First resistance, input resistance, R1 resistance is 1 kilo ohm, second is 10, third is 100. And what are the voltages? 1, 2 and 3. And what is the feedback resistance? 100 kilo ohm. So how we are going to solve this equation? So this equation we have to solve now. Okay, we'll use the different color now. So now what is the, 1 minute. Now what is the output voltage? The out equation for the output voltage is equals to your this equation minus Rf V1 divided by R1 plus V2 divided by R2 plus V3 divided by R3. Okay, so if you substitute or you can arrange this equation, so this output will be equals to your minus Rf divided by R1 into V1 plus Rf divided by R2 into V2 plus Rf divided by R3 into V3. Okay, so what are the given quantities here? Here Rf is equals to your 100 kilo ohm. Okay, and what are the R1? Here R1 is equals to your 1 kilo ohm. What is R2? R2 is equals to 10 kilo ohm. And what is R3? R3 is equals to your 100 kilo ohm. So if you substitute all these values in above equation, what is the output? Output is equals to minus, what is the feedback resistance? This is 100 kilo ohm. And what is the R1? That is the 1 kilo ohm. Okay, and what is the input voltage? Input voltage V1. V1 is equals to 1 volt. So here write V1 also. V1 is equals to 1 volt. V2 is equals to 2 volt, and V3 is equals to your 3 volt. Okay, so here now substitute the value of V1 1 plus. Okay, so this will be get cancelled. Here it will be 100, 1 divided that will be 100. Okay, second is your feedback resistance 100 kilo ohm. And what is the R2? R2 is equals to 10. Okay, 100k 10k into what is the second voltage? Second voltage is 2 plus 100k feedback resistance. What is the R3 resistance? 100k. Okay, and what is the third voltage? 3. So this is equals, this will be value 1, this will be your 10, this will be 100. So this output will get, output is equals to minus is there. This is equals to your, this will be equals to your 100 into 1 means 100 plus, here this will be equals to 1 by 100 means this value, the here this will give you 10. There this value gives you 10 because 100 divided by 10 kilo ohm, 100 kilo ohm, this will be 10. So 2 into 10 means this will be equals to your 20, and this will be divide cancel out both, so there will be only 3. So we'll get these values. 100, this will be equals to your 20 plus this will be equals to your 3. So this output voltage is equals to your minus 123 volt. Okay, so what is the output for this operational amplifier as a adder, or inverting operational amplifier adder? The output voltage is equals to minus 123 volt. Okay, so you have to write the output for this operational amplifier inverting adder is minus 123 volt. So this is about your operational amplifier problems on inverting, non-inverting and adder. Okay, so now this is the problem for you. You have to attempt this. This problem is also similar, same condition is there. Here you can write directly output voltage is equals to minus Rf divided by R1 into V1 plus Rf divided by R2 into V2 plus Rf divided by R3 into V3. Here, substitute the values of R1, what is the value of R2, what is the value of R3, what is the value of V1, what is the value of V2, what is the value of V3. So you have to take all these values, substitute all these values, and then by substituting calculate the output. Okay, but output will be minus. Okay, why it is minus? Because this operational amplifier is a inverting amplifier, means input is provided to the inverting terminal, hence we will get the output negative. So this is about your problems on adders in non-inverting and inverting. In next video lecture we are going to learn the problems on a uh, operational amplifier as a differentiator and a integrator. So we'll stop now. Thank you.